bit by bit in a bit per in a bit per second. We transmit the bit by bit in the physical layer. Okay, bit by bit, one bit at a time, 0 or 1 at a time. But if it is byte, what is the content of byte? Byte contains 8 bit. Okay, 8 bit is equal to 1 byte. So 1 bytes per second means it transmits 8 bit in a second. Okay, so in case of analog devices, the bandwidth is measured cycle per seconds. Okay, cycle per seconds means hertz in analog signals. Like your CPU also measured in terms of gigahertz. Okay, this is analog. Okay, in terms of analog measurements, but internally it's digital. But the clock speed is measured in terms of analog. Okay, hertz, gigahertz, 3.5 gigahertz. Okay, 3.2 gigahertz, 3.0 gigahertz, 2.0 gigahertz. If it is Ryzen or any other things, Intel or any processors. Okay. So let's see here. A bandwidth characterized as the measures of the data and information that can be transmitted in a fixed measure of time. See here, you are connected the internet through the ISP, internet service provider locally. NetSurf, Geo, Fiber, BSNL fiber to home or anything. That if you connect the internet in a speed of 300 megabit Mbps, megabit per second, not byte, megabit per second, Mbps, okay, megabit per second. So this is your bandwidth, 300 Mbps your bandwidth. Your bandwidth is your capacity, okay, your capacity, but you will not receive as your capacity. Your download, your bandwidth is 300 capacity, but your download is around 2 Mbps only. Okay, why not in the 300? 300 is your capacity only. Okay. So in a highway, we have 4 lane. Okay, four lane, side by side, 4 lane, two-way communication, 4 lane. This is the capacity. But in a given times that the vehicle passes through this highway is the real speed. Okay, real speed availed by the vehicle only. The capacity is the 4 lane. Okay, 4 lane. Okay. Bandwidth is only one component of what an individual says the speed of network. People frequently mistake bandwidth with internet speed in light of the fact of the internet service provider that claim that they have a fast 400 Mbps connections in their advertising campaigns. True internet speed is actually the amount of data you receive every second and has a lot to do with the latency too. Now it's very clear. Okay. Internet connect trangkhanin speed ka 300 Mbps mo 400 mo 10 Mbps ni khan 10 Mbps ang khan i-download thelo mo akachu bandwidth ti khasket to ni bandwidth za ta khan ni bandwidth ka kam za khan ni maro chu khami anga i-download thei low ani san chu kaka capacity ni ta actual speed ero chu internet speed actual ro chu data you receive every second atsuga data here receive zap zokha ani de zok ni chu ta chon latency tam takala om le the ni mo latency ka le kha bandwidth chu lo len ta se. Let's go to the throughput. What is the throughput? Throughput is the number of messages successfully transmitted by per unit time. Okay, throughput. Message successfully transmitted per unit time. It's controlled by available bandwidth, the available signal to noise ratio, and hardware limitations. The maximum throughput of the network may be consequently higher than the actual throughput achieved in every consumption. The term throughput and bandwidth are often true as the same, yet they are different. Bandwidth is the potential measurement of length. However, throughput is the actual measurement of how fast we can send. Bandwidth is the potential. Okay, this is the potential measurement of the link. What is your measurement of the link? What is the capacity of your link? What is the capacity of your router? What is the capacity of your switches? All these things are come in the bandwidth, measured in the bandwidth. But whereas the throughput is actual measurements, how fast we can send the data. In between this, there's lots of loss of data in the connections, cables, all those things. Throughput is the actual, okay, actual measurement, not considering the loss of data, latency, all those things. Okay, throughput is measured by the tabulating the amount of the transfer between the multiple locations during a specific time, period of time, usually resulting in the unit of bits per second, which can involve by the bytes per second, BPS. So here B are B capital and B small are different in the transmission. Okay, if you say Mbps, MB with capital, this is byte per second, megabyte per second. That if small, MB small, M capital, B small. Okay, this is called megabit per second. So kilobyte per second and kilobit per second, all these things. Okay, in the measures, throughput may be affected numerous factors such as hindrance of the underlying analog physical mediums, available processing of the power of system components, and the end user behaviors. When numerous protocols expense are taken into account, the useful rate of the transfer of data can be significantly lower than the maximum achievement of throughput. So there's lots of processing in the transmissions. Okay, this also considered in the throughput. Okay, bandwidth means capacity and speed means the transfer rate. Okay, so these are the factor affecting the throughput. Okay, let's go to the latency lacking. Okay, in the network latency in network during the process of the data, latency known as the delay is defined as the total time taken from a complete message to arrive at the destination. Destination starting with the times when the first bit of the message is sent out from the source and ending with the time when the last bit of the message is delivered at the destinations. So first bit and last bit from source to the destinations, how long it takes. The network connections where small delays occurs called low latency, and the network connections which suffer from long delay known as the high latency network. So this is depend on the network devices, speed of the network devices, and also the speed of the throughput, and also the MTU. Okay, maximum transfer unit. All these things controlled by this latency. High latency leads to create the bottlenecks in network connections. So there are some congestions in the network also, and also network looping also create the latency also. There are some factors influencing this latency. There's lots of factors influencing this latency. It stops the data from advantage of the network pipe and conclusively decrease the bandwidth of the communicating network. The effect of the latency of the network bandwidth can be temporary or never-ending depending on the source of the delay. Latency, also known as the ping rate, measures in a millisecond. So this latency is the ping rate. How it's ping control those latency, ICMP packet. Let's see here. If I'm pinging this facebook.com. So here we have speed, latency rate. This TTL is the time to live, how long it can survive in the network. This ICMP packet, this ping packet, and the bytecode is 32-bit, and the time round trip from my computer to the Facebook and back and forth. Okay, this ICMP packet is the 125 milliseconds and this 116 milliseconds. Okay, all these things measured in terms of this millisecond. Okay, milliseconds. Here the latency rate of this is above 70, sometimes maybe it's cross 100. That sometimes it's cross this one. Then the connectivity is not so much fast to reach to this Facebook's connectivity. But if I'm pinging the Google DNS 1.1.8.8.8, right now this Google server, if I'm DNS server, then sometimes it's below 50. Okay, now this is clear that it's measured in terms of the milliseconds. The simple time that latency may be different at the time required to successfully send a packet across the network. And so round trips or one way, and it might be affected by any components in the change in the utilization of the vehiculated data when it's moving the data. Okay. And then the next one is the bandwidth delay product and delay of two performance measured of links. However, what is the significance in the communications if the product of two and then the product of two and bandwidth delay product? So bandwidth and delay are two performance measure of the link. Okay, delay means the latency, the capacity, and then the delay, latency, is the significance in the data communication, the product of two. So this is very important in the communications, bandwidth and product delay, latency. Okay, bandwidth you already know, then delay product latency, you already understand this one. Then the last point, jitter is one of the performance issue related to delay. In technical terms, jitter is the packet delay range. It can simply means that jitter is considered as a problem when different packets of data face different delay in a network and the data at the receiver applications is time sensitive. That is audio or video. Jitter is measured in the milliseconds. It defines as the interference in normal order of the sending data packet. For example, if the delay for the first packet is 10, for the second packet is 35, and the third packet is 50 milliseconds, the real-time destination applications that use the packet experience is jitter. So each and every packet transmitted through the network having the different delay. Okay, different delay. So these real-time destination applications that use the packet experience is called this jitters. Okay, if there are different delay in the networks, so this is called the jitters. These jitters happens in especially in uh, special packets. We can say that different packets like compressed data, audio or the video, that it can cause the jittering. There are different types of delay in the network. Okay, so the arrival times delay is not same from the one packet to another packet. Okay, that's all for today. Right now we completed the unit 1. Then next week we're going to have the unit test, and also we have to start to the second unit.